Aladdin, we are going to study on the project time management, which is on the chapter 6 in our course book. So let's start our presentation. Today we're going to discuss the project time management in detail. First of all, I will give you a brief introduction about the project time management, and then I'm discussing these topics of the project time management in detail, and as a conclusion I will discuss the project scope management and project time management relationships. So let's start with the basics of project time management. So software projects requires a variety of procedures and methods to efficiently plan, organize, carry out, and oversee the operations within the project time frame. This is known as project time management. Software project can be completed on time within a budget and with the desired quality by using good time management techniques. So let's continue with the importance of project schedules. One of the manager's biggest challenges is meeting project deadlines, which frequently results in conflict because many of the workers are trying to complete the set task in the same project, and there will be a conflict because they do not know each other why they're trying to work on. And it's so simple to measure time, and we call the estimated completion date. Schedule errors are common. Differences in work styles and cultures might lead to scheduling difficulties as well. Work ethic and flexibility are impacted by cultural differences in beliefs towards timetables. Yes. As you can see in the diagram, the processes of the project planning management. First of all, we should do a planning schedule management. After, we must have to define the activities and sequences them, and then estimate activity resources and estimate activity durations we should have to do. And also, we develop schedules by several techniques, and then controlling the schedule, and we should do the project time management with these steps. So let's discuss in detail. Planning schedule management stems from the project initiation documents like the project charter specifying start and end dates, review project management plan charter, environmental factors, and process assets. Developing the schedule management plan utilizes the expert judgment, analytical techniques, and meetings. Tailor the plan based on the project needs as well. The key components of the schedule management plan is the project schedule model development, such as activities, durations, and something like that. And then scheduling methodology and tools such as critical path, critical chain, network diagram, Gantt charts. These are the all tools that we can use. Level of accuracy in units of measure, control thresholds, monitoring the schedule performance, rules of performance measurement, earned value management is one of the tools that we can use in this area. And reporting formats also is important to the scheduling things. And the process descriptions is important because we should know what we do and to create the time for that. That's why. Yes, let's continue with the defining activities. After the scope management planning, it's common to define activities in greater detail for schedule management. Review schedule management plan, scope baseline, environmental factors, and process assets. Outputs include activity lists, activity attributes, milestone lists, and plan updates. Activity list is the tabulation of activities for the project schedule, including name, identifier, and brief description. Activity attributes provides detailed information about each activity, such as procedures, successors, resource requirements, and constraints. Also, milestones is a significant event without duration, useful for setting goals and monitoring the process. Importance of activity definition is on sequencing activities, estimating resources and durations, and developing the controlling schedule. Relation to triple constraints defines the scope further, following sequence activities and estimate the resources and durations, forming the basis of creating project schedule. And the goal of the whole process is ensure the complete understanding of project works, effective scheduling, and resource allocation. Yes, let's continue with the sequencing activities. After defining activities, we should have the sequencing them based on the dependencies, and it is crucial for project time management. The inputs of the sequences activities is schedule time management plan, activity list, attributes, project scope statement, milestone list, and organizational process assets. Dependencies is the relationship between activities impacting scheduling. Types of dependencies. We have three types of dependencies, such as mandatory dependencies. This is the inherent in the nature of work, example testing after coding. Discretionary dependencies defined by project team, for example, design after user sign-off. And external dependencies relate on non-project activities such as hardware delivery affecting the software installation. And significance determines the scheduling options and influences the project timeline. Stakeholder collaboration, importance of involving stakeholders in defining activities dependencies. And tool utilization, essential for effective scheduling, tools like network diagrams and critical path analysis. So, network diagrams are the best method for activity sequencing because they are schematic displays and that show the logical linkages and sequencing the project activities. These are the nodes of the sequence diagrams, and these are the paths, and these are the numbers. We can assume the numbers like a phase and maybe creating a time management, and we can find the shortest path or the longest path that we are going to arrange the time.
This is the activity sequencing?
Yes, sequencing the activities, yes. These are network diagram is the tools for sequencing the activities. So let's continue with task dependencies. We have four types of task dependencies, such as finish to start, start to start, finish to finish, and start to finish. In finish to start, task B cannot start until task A finishes. In start to start, task B cannot start until task A starts. Finish to finish, task B cannot finish until task A finishes. And start to finish, task B cannot finish until task A starts. This is maybe kind of a language that the team workers are used in their project time management. Estimating the activity resources. To estimate activity durations accurately, understanding the resource requirements is crucial. Tools like expert judgment and data analysis and project management is a software aid in this project. Inputs such as schedule management plans, activity lists, and risk registers inform the resource estimates. Brainstorming and evaluating alternatives are vital, especially in complex projects involving multiple disciplines. The main output of the resource estimating process includes a list of activities, resource requirements, resource breakdown structure, and project document updates. So, estimating activity durations. Activity duration estimating is crucial in project time management, following activity definition and resource estimation. Duration includes actual work time and elapsed time, while effort refers to work hours or days. Duration estimates are recorded in project software related to calendar time, requiring document assumptions and updates. Inputs from team members performing the work is essential. Scope changes are necessitate updates, and seeking expert advice and reviewing similar projects is beneficial. And inputs of them is project documents factors like resource calendars and risk registers. So let's continue with the developing schedule process. Gantt chart is a tool for us to use by developing a schedule, and it provides a standard format for displaying project schedule information by listing project activities and their corresponding start and finish dates in calendar form. This is the VBS hierarchy shown by indentation. This is the activities section that we are going to state in there. And these bold lines is a summary of the task that we did with our teammates. And this is the milestones in our project. And this is the individual task for each team member. And this arrow shows the dependencies as you see in the figure. Critical path method is a common for developing a schedule that you can use. Many projects fail to meet schedule expectation. Critical path analyzing is a network diagramming technique used to predict the total project duration. It's common for stakeholders to want to shorten a project schedule estimate. So this is the network diagram as we've seen before, and we use a critical path method throughout the network diagram to see our project time estimation. For example, you can assume these numbers as a days, and the critical path method, we can use the longest path throughout the network diagram. For example, this is the longest path that we are going to use as a critical path method. So let's continue with the critical change scheduling. It's a project management technique that aims to improve project finish dates by changing the way people make task estimates. In traditional project management, people often add a safety buffer and time to their task estimates to account various factors such as multitasking, distractions, interruptions, fear of reduced estimates, and Murphy's Law. However, in the critical change scheduling, buffers are removed from individual tasks, and instead a project buffer is created, which is added from the project's due date. Another concept in the critical change scheduling includes multitasking, which occurs when resource works on multiple tasking simultaneously. Multitasking means doing the multiple works in the short amount of time. The role of buffers in critical change scheduling. The critical chain refers the sequence of tasks that determines the project's overall duration. Instead of adding buffers, individual task feeding buffers are added before the tasks on critical chain if they are preceded by other tasks that are not on the critical path. Feeding buffers help to ensure that the tasks on the critical chain are not delayed by non-critical tasks. Additionally, a project buffer is added before the project due date to protect the overall project completion date. Let's discuss with the network diagram using critical change scheduling. This diagram illustrates how critical change scheduling accounts for limited resources and includes the use of feeding buffers and project buffers. The feeding and project buffers in critical change scheduling help us to predict the project completion date, as we said before. So as you see in the figure, this displays like that as a figure. So let's discuss with the program evaluation and review technique is a PERT. PERT is a network analyzing technique used in the estimate project duration when there is uncertainty about the activity duration estimates. And it calculates the weighted average of each activity duration estimate to account risk uncertainty. PERT can help us in developing more realistic schedules and addressing the risk associated with the duration estimates. As you can see, here is the PERT formula, which is the PERT weighted average minus optimistic time plus 4 times most likely times and pessimistic times divided by 6. Yes, let's continue with the controlling schedule. Schedule control is the final process in the project time management that aims to know the status of the schedule, influence factors, causing changes, and manage changes when they occur. Tools and techniques for schedule control include performance reviews, schedule change control systems, scheduling tools and software, variance analysis, and what-if scenario analysis, adjusting leads and lags, schedule compression, and resource optimization techniques. Controlling changes to project schedules involve ensuring the realistic expectations and emphasizing the importance of meeting schedules. So let's look at the reality checks on scheduling and the need for discipline. Reality checks is like such as reviewing the draft schedule and getting the stakeholder approval and help manage changes to protect the schedules. Project managers must account for project risks and the complete behavior of the project organization. Project managers use tracking Gantt charts to illustrate the progress and understand the schedules, as we said before, and it's crucial for project managers to verify the schedule process and develop a good relationship with the team members to ensure the work is completed as planned. Successful software project implementations projects involve forming a global competence center and identifying the super users for each location and ensuring the ongoing involvement of managers in business processes and projects. So let's look at the using software to assist in project time management. Various types of software are available on the project time management, including communication software, decision support models, and project management software like Microsoft Project 2010. For example, Gantt chart is a tool for the project management, as we said before, and we can make our Gantt charts in Microsoft projects. Project management software can assist in drawing network diagrams, determining critical paths, and creating Gantt charts and generating the reports for the project time management. Words of caution on using project management software. Misuse of the project management software is common due to a lack of understanding concepts like network diagrams, critical path, and schedule baseline. Top managers often make errors in software tools like Microsoft Project, such as not establishing dependencies among the project activities or hard-coding dates. Understanding the importance of establishing relationships among the tasks and letting the software update formulas automatically is crucial for successful use of project management software. So, as a conclusion, over the course of the project, there is a close relationship between scope management and project time management. Aligning the project objectives, deliverables, and deadlines is crucial to ensuring the project's success. This may be achieved by clear scope definition and efficient change management and precise the time estimation and ongoing the scope verification. So thank you for listening. If you have any question, you can ask.
Can you explain the buffer time? The buffer time you mentioned.
Yes, buffer means in the network diagram, you can see the arrows in the network diagram, and when more than one arrow comes in the single node, it's called a buffer.
And because sometimes, we estimate time for a project and we say, okay, we're going to finish, but sometimes maybe weather or something, or maybe like a worker is sick, it could affect the estimated time. So the buffer helps
will be extended.
Yes, so the buffer actually extends the time. It's always added before the task, if you see in the diagram. The X is the task done by limited resources. So the F is the feeding buffer, which adds the time. It's always before the task.